Hi everyone. In today's lesson, we're going to talk about radian and degree conversions. So by definition, a radian measure is simply another way to measure angles. Just as we have like inches and feet, we can use two different measurements, to measure the length of something. So this is for degrees or measuring angles, right? So to convert from degrees to radian, you're going to multiply by 180 over pi. And then to convert from radians to degrees, you're going to multiply by 180 over pi. So let's do a couple of examples. So in example number one, I'm giving you an angle of pi over 2 radians. So I'm giving you radians and I want to convert from radians to degrees. So the rule for this one is that we're going to multiply by 180 over pi. So we have pi over 2 times 180 over pi. Now, if you remember, the way you multiply fractions is you multiply straight across, tops with tops, bottoms with bottoms. So 180 times pi is 180 pi. And the bottom is 2 times pi, which is 2 pi. Now you should notice that the pi's will cancel, and 180 divided by 2 is 90. So the answer, simply 90 degrees. Okay, so the next example is going from degrees to radians. So we know it's already in degrees, so we're going to do the work for the radians. So if I want to go from degrees to radians, I'm going to multiply by 1 pi over 180. So we're going to start with 225, and we're going to multiply by pi over 180. So now with this one, to make the 225 a fraction, you can simply put it over 1. And now we do the same thing as we did before. We're going to multiply tops with tops, bottoms with bottoms. So 225 times pi is simply 225 pi. And then 180 times 1 is simply 180. So unfortunately, we can't leave our answer like this because we have to put it in reduced form. So what you notice is the 225 and the 180 can be simplified. So don't put the pi into the calculator, just the 225 over 180, and then get a reduced fraction for me. Pause the video and then hit resume when you're ready for the answer. Okay, so you should have gotten 5 over 4. And then all you're going to do, since there's a pi here, you're just going to tack on the pi. And then this is your answer in radians. So what I'd like you to do now is see if you can try these next two examples by yourself. Do them right now and then hit resume and you'll see the answers. All right, these are the answers that I got. So for 17 pi over 2 radians, I got 1,530. And for negative 135, I kept the negative with it, so it's okay. And I just multiplied in. So then my answer is just going to be negative 3/4 pi. All right, so to get that, I simplified negative 135 divided by 180, and then that gave me the negative 3 over 4, and I just tacked on the pi with it. Okay, so the last example is 3 radians. Now I saved this example to do together because notice how this radian doesn't have a pi in it, but this does, and this does. So it's okay. We're still going to do it the same way. Our answer might look a little different. So to go from radian to degree, we multiply by 180 over pi. So we have 3 times 180 over pi. And we can put the 3 over 1 like we have done and multiply straight across. So 3 times 180 is 540. And then 1 times pi is simply pi. So technically, this is the answer in degrees, but it's weird that there's a pi in it. So this is the scenario where I'd actually like you to put pi in the calculator. So take a minute and literally just type this whole thing in just the way you see it. Type in 540 divided by pi and get an answer. And then hit resume when you're ready. Okay, so if you do that, you should get 171 point, it should be a decimal. So we could say 0.9 if we round it, degrees. I think it actually comes out to 171.8873 and then a whole bunch of other digits, but I just rounded it. So this would be our final answer. So if I'm giving you a problem like this, I have to tell you what to round to. So I should have said round to the nearest tenth. So basically, this scenario is the only scenario that you're going to put pi into the calculator because leaving it as 540 divided by pi doesn't really make sense in degree form. All right, let's take a look at the back. So example number 2 says, graph 7 pi over 6 on the axes below, and then determine the following. So state a positive coterminal, a negative coterminal, and then state and label the reference angle. So in order to graph something, I need it to be in degrees. So I'm going to take this 7 pi over 6, and I'm going to change it to degrees by multiplying by 180 over pi. So same thing that we've done before. So we're going to multiply straight across. 7 times 180 gives me 1,260 pi. And then the bottom, 6 times pi, gives me 6 pi. The pi's will then cancel, and I can divide 1,260 divided by 6. And that gives me 210. So basically, I'm saying graph, not 7 pi over 6, I'm saying graph 210 degrees. So we remember positive angles go counterclockwise. So we probably should label the pieces. So here's 180, 270, and then 360. So 210 degrees is probably going to be somewhere after 180 and in between 270. So remember, when you graph an angle, you need 3 pieces. You need your initial side, which is always going to be at the 0 marker. Then you have your terminal side. 210 is probably closer to 180 than it is to 270. And then you also need your directional arrow. So we start at 0, we go up and over and follow around, and that would be your 210. And then it also tells us to do a couple of things. So we've graphed it. Now I know it says graph 210, so maybe we should graph it since it says graph 7 pi over 6. So let's write that instead since they want it in radians. So 7 pi over 6. So now it says state a positive coterminal angle. Then it says state a negative coterminal angle. So for part A, remember, a positive coterminal angle, all that it means is that we're going to add or subtract 360. So 210, in order to get a positive number, we're going to have to add 360. So 210 plus 360 is 570. And then I'm going to leave us some space. And then it says state a negative coterminal angle. So in order to start with 210 and to get negative, we should subtract 360. Now you could subtract more than once. I'm just choosing to do one time. So this would be negative 150 degrees. But notice the directions are saying specifically state a positive coterminal angle in radians. So your next mission now is to change the 570 and the 150 back into radians. So remember, I'll do the first one with you. 570 times pi over 180 will give us back radians. Put the 570 over 1 and multiply tops with tops, bottoms with bottoms. So 570 pi over 180. Now remember, this has to be simplified. So go ahead, simplify that, and then hit resume when you're ready. All right, so it looks like you should be getting 19 over 6. So I'm just running out of space. So 19 pi over 6 should be your final answer there. So I'm going to leave you guys to finish question part B. So I'll leave that for homework. So you need to convert this negative 150 into radians. And then the last part is going to be to state and label the reference angle in radians. So remember the definition of a reference angle. A reference angle is the acute angle formed by the terminal side of the angle, this is my terminal side of the angle, and the x-axis, which would be here. So that angle, to form it, is right in here. So this is my reference angle. We have to figure what that is in radians. So what I'm going to do is figure it out in degrees, and then your homework will be to put it back into radians. So remember, if you are in quadrant 3, so here are your reference angle rules. If you're in quadrant 1, the angle itself is the reference angle. If you're in quadrant 2, it's 180 minus the angle. If you're in quadrant 3, it's the angle minus 180. And if you're in quadrant 4, it's 360 minus the angle. So we are in quadrant 3. So the angle, the original angle, is 210. So 210 minus 180 gives you 30 degrees. So this is my reference angle in degrees. So part of the question says put it back into radians. So that is going to be your last part of homework. Change this 30 degrees into radians. All right, that's it for today. If you guys have any questions, now is a good time to jot them down. Otherwise, we'll see you in class tomorrow. Have a good night.